The same reaction of haloalkene with aqueous KOH gives alcohol via substitution, but reaction with alcoholic KOH gives alkene via elimination. Explain. You have to explain this. Since alcoholic KOH contains alkoxide, see, this was the answer, but you don't have to write this much, all of these things. You need to concise this answer because this answer may come in 2 marks on its own also, and sometimes they have asked in 1 marks also. Okay, so this is the answer for if they ask even in 3 marks because you have written everything here. What are the crux of it? Also, one more thing is that you have to see what are the words which are important here. So in question, obviously, they're not going to give you that it happens via substitution and it happens via elimination. So these are the 2 words that you have to mention. Okay. Since alcoholic KOH contains alkoxide ion, this is important. Is stronger base. This is an important one. Due to larger size and high electron density. Now, this stronger base tak aap likh dijiyega agar. That means the teachers know that you know what is going to happen. If it is stronger base, if it is acting as a base, that means it is going to eliminate hydrogen. What does base do? They abstract proton. They don't attack on carbon atoms. Base do not do that. Base, they abstract the hydrogen atom. But in aqueous KOH, hydroxyl ion is present, which is weaker and good nucleophile due to smaller size. So due to small size, that you don't have to write. Once it is a good nucleophile will attack on the carbon atom, not at the H plus, because that is the function of a base, not nucleophile. So these are the 2 main difference. This is a base. Alcoholic KOH is a base. Aqueous KOH is a nucleophile. That is the main difference. And this happens via substitution, and this happens via elimination. This happens via elimination, and this happens via substitution. Okay, so these are the some crux words that you have to remember. Okay, fair. So let us move on to today's class. Please write this question, send the answers to me. Khalid and Salman, what did you make for the project? Computer science project?
We made an ATM machine.
ATM machine?
Yeah, like accounts, you can store accounts.
Congratulations, man. Why are you still studying?
I mean, we don't
kind of the basics of it. Like, we didn't learn much at school, right? So we just made using if and if else statements and all.
Conditionals. Okay, fine. So
we don't have
what
database yet.
What do you don't have?
Database software.
Actually, you don't have a database, but like you must be using the inbuilt databases, right? Like dictionaries, maybe.
But our school didn't still start the part of that.
Dictionary also they have not started.
Dictionary they started, yes.
You can just have dictionaries.
You're trying to implement that.
Okay, what about classes? Have you done classes? Like object-oriented programming? Do you know how to make class? No.
I think I don't remember.
Okay, fine, no problem. Yes. Khalid, correct. Umar, you did not give the test. You were not present in the last week, right? No. Samira, try the second one once more now. First one is fine. You see, you have done something extra in the second one. Count the number of carbon atoms and think in that way. As to write these things more clearly, na? Like the bond will be between what? Carbon or carbon oxygen. That is not very clear in the second one. And for the first one, it is fine. Second one is okay. Here or in WhatsApp, Umar? There only, okay. I'm still waiting for answers. Please send me Hishma. And who else is here? Assalamu alaikum, Maimuna.
वालेकुम सलाम सर.
Like आप तो इतना nonchalant you are saying आप बहुत दिन बाद आ रहे हैं.
Yeah, so actually I was on a vacation, so.
So you were watching the lectures या फिर नहीं?
No, I was in contact with the subject though, but I didn't watch the lectures.
Okay, fine. So can you answer these?
Yeah, I mean I can try.
Try at least. Okay, Nawal. This Nawal, correct. Samira, you have. Now it is correct, Samira. I hope you understood it also. Like you were in a vacation, like मतलब किसी और मतलब कहीं और गई थी क्या पूरी दुनिया अलग दुनिया में या हिंदुस्तान और मिडिल ईस्ट के ही बीच में कहीं?
No, I went to India.
India only ना?
Yeah.
Okay. हमको लगा आप दूसरे गांव चले गए ना क्या? परदेश.
No.
Okay. Matthew, correct. Matthew, can I ask you something?
Yeah, sir.
मतलब कुछ थोड़ा सा भी चांस है handwriting ठीक होने का?
Sorry, sir. I was a bit reckless in that. Yeah, I will improve it.
Anna, please improve it. Okay, like, okay, Saf, seeing yours now. Saf, you have missed a word. I can see that. Also, आपने तस्वीर पूरी नहीं भेजी है. I think for the first one, reactants are fine. Second one, I can understand the reactant, but also you can see that there is something missing, right? It's not complete, and it's also not correct, by the way. It is not also. It's not correct also. We have done this yesterday only. Please look into it. Hishma correct. जिन लोगों का handwriting खराब है, I'm really saying, like, people are biased. Humans are biased. The world is not fair. If someone is having good handwriting, उनके लिए खुशखबरी है. Like, that's a good news. That the person who is going to check it, it will bring coolness in his eye. He will be calm while he's checking that paper. Okay. So अब उस calmness के लिए ना वो बच्चे को थोड़ा जैसे बहुत गंदे गंदे handwriting के papers आए, उसका एक बहुत अच्छा handwriting का पेपर आया, तब उसको थोड़ा शांति होगा. चलो ठीक है, कुछ साफ साफ है, हमको ज्यादा सोचना नहीं पड़ेगा. Whatever is written, I can read it entirely. I don't have to put my mind. हमको सोचना नहीं पड़ेगा कि क्या लिखा है इसमें. So all of those things, please consider it. Okay. तो आपको थोड़ा सा कम मार्क्स ना इस वजह से मिल सकता है क्योंकि आपकी हैंडराइटिंग खराब थी. डू यू रिमेंबर? आई डोंट नो. हैव यू सीन दैट एड, एक्स्ट्रा मार्क्स फॉर गुड हैंडराइटिंग? नो वन हैज सॉ दैट. डू यू नो दिस?
Renault, I guess.
No, not Renault. I think it is for Apsara pencils.
Yeah,
Oh my god, why am I advertising? Huh. So extra marks for good handwriting, that is a thing, by the way. Okay. Okay. Let us look at this problem here. Ethoxy benzene. So ethoxy benzene will be O, then CH2, and then one CH3 here. Now we can make this. This is retrosynthesis arrow. I am glad that many of you remember this. And this can be made by, I hope, the CBSE people. They will understand because most of them will be MSc people. And in MSc, we have a subject that is called retrosynthesis. So this can be made by ONA. One, two, and then haloalkane, like Br. 2-methyl 2-methoxypropane. So this is 1, 2, and 3 carbon atoms. So prop, and then we have a methyl group here. We have a methoxy group here. So ONA plus CH3Br. And it cannot be the other way around. Okay, we cannot have here. We cannot have ONA, and we cannot have here Br. I hope you guys remember it from the last class. So these are the product. Now let us write. Okay, so these are the only two methods of preparation. Now we are going to do the physical properties. Okay, please write physical properties. Also, I hope all of you have received the schedule for the next week's test. Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Yes. Yes. Anyone who has not received, वो बताएं please. जिनको मिल गया वो तो ठीक है. Okay. All of you are informed about it, right? Okay. Astha, are you in any group? You are in a group, right? Astha?
Sir, I'm there for physics. I'm not there for chemistry, any group.
तो फिर ये बोलिएगा नहीं क्या आप? ठीक है. अभी हम ऐड कर देते हैं आपको. This is what. I'm adding that number only, right? I think see, I have added you. Okay. Can you please confirm that, Astha?
Yes, sir. Yes, sir.
Yeah,
I'm added.
so you have a test on next week, Thursday. That will be, I think, 8th, right?
I think, yeah, 8th.
September. And the topic will be alcohol, phenols, and ethers, because this is the last class, full chapter. Alcohol, phenols, and ethers. Okay. So I want to be done with all of the chapters which I have done till now. And after this, we will be taking small tests. And for example, alternate weeks. Say after alcohol, phenols, ether, I will be taking for aldehyde, ketones, and carboxylic acid. But whatever topic is done till the last week. Okay. After that, I will be doing in the next week. I will be doing solutions and haloalkane, both of these chapters. In the next class, again, I will be doing aldehyde and ketones. After that, I will be doing solutions, haloalkane, alcohols. In the next class, again, I will be doing aldehyde, ketones, whatever is going on. After that, I will be doing like for all the chapters. Then I will be mixing things up. Okay. So that's why be in contact with your studies. Okay. Okay, right, for physical properties, first of all, let us see the structure of ether. So the structure of ether is something like this. Some R dash, there are lone pairs here, there are lone pairs here. If you see the structure, it is similar to that of water, but the only difference here is if I tell this is theta and this is alpha, then alpha will be greater than theta. Why? Because this R groups are bulky groups. It is bulkier than hydrogen, comparatively speaking, right? And that is why they will repel each other, making the alpha greater. If the alpha will be greater, it will be approaching towards, this alpha will be approaching 180 degree. So you may say that this is more bent than this. Okay, and that is why also this dipole moment of ether is also very less. So the conclusion that you can draw from here is ethers are slightly polar. Ethers are slightly polar. If you imagine it like this, no, then it is going to be non-polar, right? This is going to be non-polar. I think I've made the opposite directions. Yeah. See, the dipole moment here is delta positive, and here we have delta negative. So both of these are directing in the opposite directions, right? And that is why it will be non-polar. And if it was linear, but it is not completely linear, it is slightly bent, and that is why slightly polar. Slightly bent, and that is why slightly polar. Right, next point. Ethers have lower boiling point. नबील अहमद ज्वाइन ही नहीं कर पा रहे हैं. Lower boiling point than alcohol. As alcohols can form lower boiling point than alcohol, as alcohols can form hydrogen bond, but ethers cannot. Okay, so alcohol can form hydrogen bond because it has a OH bond, and whenever you have a OH bond, those molecules can form hydrogen bond with themselves. Okay, they can form hydrogen bond with themselves. Right, next. Boiling point of ethers. Slightly higher than, I think is hoga na, boiling point is hoga. Boiling point of ether is slightly higher than that of hydrocarbons. Hydrocarbons means alkene, alkene, alkenes, hydrocarbons. And we always compare with comparable molar mass. Boiling point of ether is slightly higher than that of hydrocarbon of comparable molar mass. Nabil, did you join?
Yes, sir.
Okay. What happened? Is your network not good today?
Yes, sir.
Okay, okay. We have started just now only. Okay, we have not done. We are just doing this question. जो हम लोगों ने last class में भी किया था. Okay. And Nabil, did you get the marks?
Yes, sir.
Any problem?
No, sir.
नो ना, ओके। बॉय आपने ना काफी जगह बहुत लंबे आंसर्स लिख दिए हैं एंड मार्क्स के अकॉर्डिंग उनकी जरूरत नहीं, सो आई थिंक हमने वो भी पॉइंट आउट कर दिया था आपको, राइट?
Yes, sir.
Okay. Boiling point of ethers is slightly higher than that of hydrocarbons of comparable molar mass. Why? Because hydrocarbons are completely non-polar and ethers are what? Ethers are slightly polar. Okay. You will write next. Let us talk about the solubility. So when we look at solubility, we'll be looking at solubility of ethers in water. So water has HOH kind of structure, which is bent, and ether will have, let us say, something like this, ROR. Now this lone pair is there. So what it can do, it can interact with this hydrogen atom of water. Okay, it can interact with this hydrogen atom. See, in ethers, there is no hydrogen atom. That's why it cannot form hydrogen bond with itself, but it can form hydrogen bond with water because of the presence of lone pair. It has lone pairs, and those lone pairs are what? Electron rich, and they can interact with the electron deficient water. So this is delta positive, this is delta negative, and that is why these can interact and they can form hydrogen bond. You'll write next. Ethers are soluble in water. Their solubility is comparable to that of alcohols, as ethers also form hydrogen bond with water. Similarly, as in alcohols, if I increase the number of alkyl group, if I increase the number of carbon atoms in alkyl group, the solubility decreases. Here also the same thing will happen. Increase in number of carbon atoms on alkyl group the solubility decreases. Acha, by the way, for other subjects, do you get check the answer sheets?
We get corrected papers, not
You get correct.
like she shows it.
Acha, he just shows you that यहाँ पे आपने mistake किया, यहाँ पे mistake किया. Okay.
No, sir. Maths we do, sir. He ticks and he marks, points out.
Okay. In the PDF only?
Yes, sir.
Actually, I don't correct in PDF actually. I just look at the PDF and then I have a sheet and I then put the marks there for each question. Okay. So Umar, if you remember, so this oxygen part here, this is the only part which is favorable, right, for solubility. Yes or no, Umar? Correct? Because this is making hydrogen bond. Okay. And if we are going to increase the size of this alkyl group, if it is going to be bigger, then it will be keeping other water molecules away, and it will not let this oxygen atom interact with the water molecules, right? And that is why the solubility decreases. Got it? When the alkyl group will be bigger, it will be pushing away the water molecules, because obviously this alkyl group, it is non-polar. It cannot form hydrogen bonds. So if it is not forming hydrogen bond, it will be keeping the water molecules away. If those water molecules are away, the oxygen cannot interact with them. It becomes more dominant. Correct. The unfavorable part becomes more dominant. Then everyone, yes or no, please tell me.
Yes, sir.
Right, next, chemical properties. By the way, in ethers, this physical property that I have wrote now, that is also very important. For example, they will ask you why ethanol has higher boiling point than methoxy methane. Okay, so these type of questions they will ask. They will also ask like why is, in general, they can ask why is alcohols they have higher boiling point than ethers. Why ethers have lower boiling point than alcohols? Okay, of comparable molar masses. So the answer there, the crux what there is that alcohols, they form hydrogen bond. Ethers don't form hydrogen bond. So if you write like one page also and you don't mention the word hydrogen bond, then it is going to be all in vain, I can say. Like you will not get marks for anything, even if you write one page and you don't mention the word hydrogen bond. Okay. Right, next, chemical properties. In chemical properties, the first type of reaction that we are going to look at is the cleavage of CO bond. अच्छा, wait a second. उमर को बस हम ये भेज देते हैं. Umar, I have sent it to you. Cleavage of CO bond, please write. Treatment of ethers. With halo acids, or we can say hydrogen halides, HX, leads to formation of alcohol and alkyl halide. So for example, if you have some R, O, R, I'm taking a symmetrical case right now, okay? So please remember, this is a symmetrical case where you have symmetrical ether is what? When you have both the alkyl groups are same alkyl groups. And when I react this with HX, so one of the R group is going to get the hydrogen and the other R will get the halogen atom, like this. So you can say that something like this. So attack and it will take this up. This will attack and this will take this up, okay? And this bond is going to break. CO bond is going to break. So for symmetrical ethers, it is going to be very easy and very, for examples, you can write A part, symmetrical ether. Okay, they can also ask, these question has also been asked, what is symmetrical ether? What is unsymmetrical ether? Symmetrical ether is that ether in which there are same alkyl groups on both sides of oxygen atom. Unsymmetrical, we have different alkyl groups on both sides of the oxygen atom. So for symmetrical ethers, for example, let us start with a simple one. If I have CH3O CH3, and I treat this with, let us say, HI, this is going to give me CH3OH plus CH3I. I hope everyone can see this and keep in mind, in most of your textbook now, In NCERT, they have only treated this with HI. Okay, so I am also writing all the questions with HI only because HI is also very fast. This HI bond is very weak. That is why this oxygen can easily attack on this hydrogen atom and it can do the further reactions. Okay, so please write the product for these. I'm making some. The B part, you'll understand about the unsymmetrical ethers. Okay. If you're done writing the product, now please raise your hand. Asta, send it to me then, if you're done. Correct, very good. Easy only, right? Saf, done?
Yes, sir.
Send it to me. Maimuna?
Yes, sir.
Are you done?
Yeah, I'm doing.
Doing it? Okay. Try to look at the pattern and just tell me if you need any help. Nawal, done?
Yes, sir. Sending.
Okay. Nabil Khan, what about you?
Yes, sir, I'm doing.
Doing? करके भेजिए, ठीक है ना? आप नहीं भेजते हैं, बिल्कुल आपको नाम लेना पड़ता है जब भी. घर जाके पढ़ाई करते हैं? घर जाके मतलब क्या, मतलब क्लास के बाद पढ़ाई करते हैं ना?
Yes, sir.
Okay. Saf, number of carbon atoms count करते रहिए, ठीक है ना? Your number of carbon atoms count कीजिए in the first question for the reactant and product, and then tell me, is it right or wrong? Salman, fine.
For which question, sir?
This one. Matthew, yeah, correct, fine. Oh no, wait a second. Salman, अभी आपका देखना. Salman, yeah, correct. But second one का second product जो आपने बनाया, that is थोड़ा सा और ठीक बनाया जा सकता था. But Nawal, yours is also fine. Okay, Nawal, yours fine. And Samaira. Same. Correct, Samaira. Nabil Ahmed. Very good, Nabil. Asan hai, right? Okay. Maimuna, what about you? Maimuna, do you have my number? I don't think you will have my number, right?
Your personal number?
हाँ, अब तो सबके पास है. Maimuna is like.
No, I guess I don't.
You are not in any group also, I think, right? Sorry?
No, I think I am. My dad's.
Your dad's number is there. Okay, fine. So do you have any phone? Like, do you use any phone so that you can send me answers? Okay.
Yeah, I have my own phone.
Send the answer to me.
Sir, please check now.
Saif, आपके एक सेकंड हो जाए. Khalid, fine. Saif. अब number of carbon atoms आप count कीजिए. कितने reactant में? बताइए. How many do we have in the reactant? How many carbon atoms? Omar, उमर सी आयोडीन जहां लगाया है आपने, कुछ आपको गलती दिख रही है अबाउट द नंबर ऑफ हाइड्रोजन्स? मोहम्मद उमर, yeah, CH3 CH2. Okay, see here, please. Saf, tell me how many carbon atoms do we have here? How many carbon atoms?
2 on the left, 2 on the left, 2 on the right.
Sorry,
We
what
have
did you
two.
say?
We have
There
2
only
carbon
two.
on the left and 2 carbon on the right.
Very good. तो यहाँ पे आपके पास ऐसे लिखिएगा ना, 1 2 कार्बन हो गए, 1 कार्बन 2 कार्बन एंड देन OH प्लस 1 कार्बन एंड 2 कार्बन एंड देन आयोडीन,
Yes, sir.
राइट?
Yes, yes.
देखिए एक ये होता है, दिस इज 2 कार्बन एटम्स, बट नाउ दिस इज 3 कार्बन एटम्स. ओके, क्योंकि यहीं से स्टार्ट किया हमने. नाउ इट इज 4 कार्बन एटम्स, नाउ इट इज 5 कार्बन एटम्स.
Yes, sir.
जब भी आपको नंबर ऑफ कार्बन एटम्स गिनने हो ना, आप ये देखिए, ऑल ऑफ यू नो माउंटेन्स, राइट? हाउ मेनी माउंटेन्स आर देयर, टेल मी?
2.
2 माउंटेन्स, देन इट विल बी 2 into 2 + 1, 5 होगा. माउंटेन को डबल करके 1 कर दीजिए अगर आपके पास कंप्लीट माउंटेन्स है तो. इफ यू डोंट हैव कंप्लीट माउंटेन्स, फॉर एग्जांपल इफ यू हैव दिस मच, हाउ मेनी माउंटेन्स डू वी हैव, टेल मी? हाउ मेनी?
2.5.
नहीं, हाँ तो 2.5 है तो उसको कंप्लीट कर दीजिए, हाफ को कंप्लीट कर दीजिए, कितना हो जाएगा? 3 into 2. हाँ, 3 into 2 कर दीजिए, फिर 6 हो जाएगा. ठीक है, यहाँ पे अगर आपके पास कंप्लीट माउंटेन्स है देन व्हाट यू हैव टू डू. बट हाँ, ये ध्यान रखिएगा आप लोग प्लीज. फॉर एग्जाम्पल अगर बीच में ऐसे यहाँ पे ऑक्सीजन आ गया, सो नाउ यू डोंट हैव 5, यू हैव 4 कार्बन एटम्स. 5 एटम्स है आपके पास, जिसमें से 2 कार्बन है और 2 कार्बन इधर है, 4 कार्बन है और 1 ऑक्सीजन. ओके, okay, so here it will be no. Umar, it is having a ring, no? Consider that also. Okay, right, next one, unsymmetrical ethers. In unsymmetrical ethers, first of all, we will see what is going to happen if we have 1 degree. So if you are going to have 1 degree, for example, if you have CH3O, CH2, CH3, plus let us say HI, then it is going to give, see, you have only to, you have for first 1 degree and 2 degree, you have to make the alkyl halide first of all. Less hindered alkyl halide. You have to make less hindered alkyl halide. So you will see that here we have this CH3 is less hindered, right? This side is less hindered. So this will make what? This will make alkyl halide. So you will get CH3I plus CH3CH2 OH. Second one, if you have 2 degree, then here also you are going to make less hindered because both of these are what? SN2 type of reactions. Okay. So here also you are going to get CH3. And if you have O, carbon, hydrogen, CH3, and then again a CH3 here. So if there is 1 2 degree, then also here also what we are going to make? You are going to make less hindered alkyl halide, CH3I plus CH3CHOH and CH3 here. But this both of these are SN2. This is also SN2. But if you are going to have 3 degree, then it is going to be SN1. In this case, I will write the whole mechanism. So you'll have CH3, which is bonded to oxygen, which is further bonded to a carbon atom, and this carbon atom has 3 carbons. So you can see that this is 3 degree. Now this oxygen atom will have some lone pair electrons, and we are doing this reaction in the presence of HI. So from HI, there will be H plus. This H plus will be first attacked by this oxygen atom, and you will be getting oxygen with the methyl group as it is, and with the new hydrogen atom. And then it has another bond with CH2, which has 3 carbon atoms. Now this has 1 lone pair already, so it has 3 bonds. So ये CH3 आएगा, ठीक है? This is CH3. इसको हम लिख ही देते हैं आप CH3. Now this oxygen atom, it has now positive charge. Now what it can do, it can break two bonds. What it can do, it can break two bonds. It can either break this bond. So if it breaks this bond, you are going to get CH3 positive, right? Now that is not stable. Another thing is that our iodine negative can attack on this. Our iodine negative can attack on this carbon atom, right? But that is also not possible because we have here 3 CH3 group, which is completely hindered. So iodine negative cannot react until unless we get a carbocation. So iodine negative will be waiting for the carbocation, and oxygen will see that, okay, fine, I will take these electrons so that I can make a 3-degree carbocation. Okay, so this carbon atom here, this carbon atom will get a positive charge because the oxygen is taking its bond, and I will be getting CH3 OH plus this carbon atom, which has 3 methyl groups attached to it. Okay, all of these are methyl groups and a positive charge. Now this carbon atom can be easily attacked by iodine negative because it has this orbital is there, this orbital is there, right? The complete p orbital is there, and we can attack the carbon atom by iodine negative. It will attack, and it is going to form carbon with 3 CH3 groups and iodine. Okay, and this happens via what? This happens via SN1 mechanism. Formation of carbon, then we have the attack of nucleophile. And this is also one of the most favorite question of NCERT and also CBSE in ethers portion. No, this is not an exception. It's an example how things work in. See, whenever you have substitution reaction, it can go either ways. It can either go SN1. In general, देखिए दोनों चीजें होती हैं. Organic chemistry is all about probability, and there are always 2 or more things happening, and which will be more dominant. So in this case, SN1 is more dominant. Why? Because there is a formation of 3-degree carbocation. This 3-degree carbocation is more stable. Okay, this is more stable carbocation, and that is why it is formed. In order to make a product, this SN1 pathway is more efficient. That is why the system, our organic chemistry molecules, these are using the SN1 pathway. नहीं, साइक्लो आपके पास सब्स्टिट्यूएंट से पहले नहीं लगता ना मोहम्मद उमर. साइक्लो तो पेरेंट से पहले लगता है, राइट? आपका भूल गए क्या आप सब कुछ? तुक्का मारे जा रहे हैं बस आप. Okay, so this is important. Done everyone? Yes or no? Please tell me.
No one, sir.
अच्छा एक सेकंड. हाँ चल ठीक है, हाइड्रोजन मिलाया हुआ. I thought I have not added the hydrogen here. Please write, please write. Okay, so if they will ask now why is tertiary alkyl halide formed, you will say since there is formation of three-degree carbocation which is more stable. The reaction occurs via SN1 mechanism and forms 3-degree RX alkyl halide. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Yes, sir. Done.
Okay. Now, right next, if you have alkoxy benzenes, C part, right? Alkoxy benzene will have a structure like this. Now, in cleavage of CO bond, one of the bonds can break. Either this, we can say either this blue bond will break or this red bond will break. Tell me which is easier to break, the blue or the red? Which CO bond is easier to break? Blue or the red one?
Red.
Why? Tell me.
Because it is only 1 degree.
No. और देखिए, और अच्छे से देखिए, which is easier to break? Samaira, why? Answer in chat only, no?
Blue one, sir. It will be difficult
Why?
to break because blue one is having partial double bond character.
Correct. So whenever you see this fragment, ना देखिए ये सारी चीजें ना दिखनी चाहिए. जैसे अभी आप लोग, most of you can see the number of carbon atoms, right? Hopefully, but here what you can see that there is partial double bond because resonance is there. सैफुल्ला आपको दिखा नहीं दिखा? बताइए. सैफुल्ला?
Yes. No, sir.
नहीं दिखा आपको? You know ना that this.
Yes, I forgot that part.
अच्छा, forgot. लेकिन ये देखिए, ये है ना भूलने वाली अब चीज नहीं, ठीक है? For example, अब ये सारी चीजें ना बिल्कुल ऐसे रहना चाहिए on your fingertips. You have to see these things. Whenever you see benzene ring attached with a key atom, and this oxygen atom will, if this atom here it is having lone pair electron, that means it is going to have a partial double bond character. Okay, that's why it is difficult to break. So this will break, and if this bond is going to break, then you are going to form phenol, right? The alcohol part will be formed from here, and you will be getting R. What else? HI. Then you'll be getting RI. Okay. So you write an example. What will be the products for CH2, CH3? This is also important. This has also been asked. They're asking like when ethoxy benzene is reacted with hydrogen iodide, why do we get phenol and iodoethane? So you will answer that. The CO bond between benzene and oxygen is very strong because it has partial double bond due to resonance. That is why that bond does not break. But which one will break? The CH2O bond will break. Okay, the CH2O bond will break of E, and that is why we get the product.
Sir, can you repeat that answer?
लिख देते हैं. अदर CO बॉन्ड ऑफ अल्काइल ग्रुप इन जनरल हम लिख देते हैं ना. क्वेश्चन तो ऐसे आपका आएगा कि मिथॉक्सी बेंजीन है, इथॉक्सी बेंजीन है, आप उसे सबसे चेंज कीजिएगा. डज नॉट ब्रेक, रादर CO बॉन्ड ऑफ alkyl group breaks and forms iodoalkene and phenol. ठीक है. So I hope you have written the product like this: OH and CH3 CH2 I. Right, next, benzyl alkyl ether. C, D part. Benzyl alkyl ether. So what is benzyl alkyl ether? Benzyl is benzene ring with a CH2 group. So it's benzyl group, okay? Only benzene ring, it is a phenyl group. Because benzene का जो पुराना नाम था वो phene था, ठीक है? So normal feature वहीं से चला रहा है, ठीक है? Benzyl is benzene ring with CH2 group. Benzene ring with CH2 group. It has oxygen atom.
Top paragraph, what you could say.
Sure. This part. Now any one of these bond will break, right? Either this red bond will break or this blue bond will break, okay? Now we can easily see that if the red bond will break, you will have a positive charge on this carbon atom, right? And whenever we have a positive charge here, then what is going to happen? It will be stabilized by resonance. There will be delocalization of the positive charge around the all benzene ring because it is a key atom, can take part in the resonance, right? And that is why this red bond will break rather than the blue bond. Okay, so after this you will write. So जो bond break करता है, that is only going to form your haloalkene. So you'll get CH2, the presence of HI, CH2I plus ROH. Cleavage of CO bond of benzyl group leads to resonance stabilized carbocation. Hence that bond breaks and forms benzyl halide and alcohol. इसमें last part है diaryl ethers. In diaryl ethers, both of these will be aromatic benzene ring on either sides of oxygen. We have so HI. Now both of these are what? Partial double bond, and that is why there will be no reaction. as both CO bonds have partial double bond character. Due to resonance, none of them breaks. And it gives no reaction. With HA. Done, everyone? Yes or no? Please tell me.
Yes, sir.
Right, next. Electrophilic aromatic substitution of ethers. In this, you will write the first point. Alkoxy group. Alkoxy group is an activating group which increases the electron density at ortho and para position. At ortho and para position. Making it ortho para directing. Ortho para directing group. Okay, so you can also write we have some O group, right? We have oxygen atom, and then it is attached to some R. So the lone pair electrons will take part in resonance like this. This lone pair will form a double bond. This double bond will form a negative charge. And here I will be getting a double bond oxygen with a R and a positive charge because it has lost some electron and it is formed in the bond. This bond will get a negative charge here, and these bond will be as it is. Now again, this negative charge will move here. This pi bond will make a negative charge. Double bond, and then you have double bond OR positive. Further, you can make another resonating structure like this. Okay. The overall conclusion is that this will lead to a OR, which is partial double bond here, and all of these bonds are partial double bond. There is delta negative charge here in the ortho position, para position, and also this ortho position. Okay, that is why it is ortho para. There are further more resonating structures. Okay, complete it like after the class. 10 guys, yes, no, please tell me. Done or not done?
No, wait, sir.
Wait.
Done, sir.
Okay. Waiting. Mamuna, you are following, right? No problem in following. अच्छा, also you will have a test. Okay, हाँ ठीक है, मैं बताती हूँ आपको. Topic will be the complete alcohol, phenols and ether chapter.
Yes, sir.
So total,
Yes,
how
sir, done.
many structures are there?
Sorry.
So total, how many resonance structures are there?
आपने कितना बनाया?
5, sir.
5 बनाने के बाद आपको वापस से वैसे ही स्ट्रक्चर मिल गया फर्स्ट वाला जैसा 5 बनेंगे. हाँ.
Yes, sir. But benzene is having alternate double
है ना?
bonds.
बस काफी है. And you will have got the next negative charge on the ortho position, right?
Yes, sir.
है ना? इसके बाद एक स्ट्रक्चर बनेगा, उसके बाद then again this one with alternate double bonds, like the double bond will be here, here and here, right?
Yes, sir.
हाँ बस. चलिए. Right, next halogenation number 1. CBSE has asked only one question till now from this topic, and we will do that also. And उसी से बिल्कुल halogenation से. Right here. This is anisole. Plus Br2, and here we use acetic acid. Acetic acid is a solvent. Okay, it does not have to do with anything with the reaction. It's just a solvent because anisoles, these are more soluble in acetic acid. That's why we use it. So we'll get two products, OCS3 in the ortho. Plus OCS3 in the para. This is major. This is minor. Okay, so this is anisole. This is what? O-bromoanisole. And this is P-bromoanisole. So the easy conversion that the CBSE asked was, how will you convert anisole to P-bromoanisole? Okay, so you just need to add Br. You don't even have to mention the solvent in CBSE examinations. Okay, if you remember it, well and good, but don't focus so much on solvent. Except in the case of CS2 and bromine water, that was in phenol. There the products change. So whenever those kind of things are there, we have explicit notes and explicit remarks there. Otherwise, you don't have to remember about the solvent. In my MSc class, we had 24 students, and our organic chemistry teacher, and he came in the first class. He was like, stand up, and everyone, he did not ask names. Tell me his name of one of the solvents, and he asked 24 solvents. So yeah, like there are more than 24, I think, solvents that are used. Generally, we use water, ethanol, acetic acid, DMSO, acetone. These are the major ones, but again, there are some exotic solvents also. So solvent chemistry is also one of the branch. Even after you do MSc, people do PhDs in solvent chemistry, right? Second part, Friedel-Crafts alkylation. I remember I said diethyl ether, which is one of the solvent. This one, diethyl ether. Friedel-Crafts alkylation. In Friedel-Crafts alkylation, again, we'll start with anisole because we are seeing the electrophilic aromatic substitution of anisole. That is the ether here. Plus, we will be using CS3Cl in the presence of anhydrous AlCl3, halogen carrier, AlCl3. And this case, what is going to happen? We'll have the anisole as it is. Alkylation will happen. That means our alkyl group CS3, that is the methyl group, it will attach on the ortho and para position. So this is anisole. This is 2-methoxyanisole. This is 4-methoxy. Sorry. Methyl होगा यहाँ पर. 2-methyl anisole. This will be 4-methyl anisole. Third one, Friedel-Crafts acylation. Friedel-Crafts acylation में OCS3, CS3 C double bond O, Cl, again in the presence of a halogen carrier, anhydrous AlCl3, OCS3. Here I will be getting C double bond O and Cl. Thus I will be getting a para product, anisole as it is, C double bond O. Sorry sir, Cl नहीं होगा, CS3 होगा, my bad. Cl तो निकल जाएगा halogen carrier के साथ. Here I will be having CS3. Fourth one है आपके पास nitration. So H2SO4. ये भी रिएक्शन बहुत आसानी से नहीं होता है. NO2 plus NO2. Write a note. Anisole does not undergo sulfonation. Because in the presence of concentrated H2SO4, the ethereal oxygen means this oxygen है ना, ये oxygen जिसकी वजह से ये ether है compound पूरा का पूरा, that is ethereal oxygen. The ethereal oxygen gets protonated and benzene ring gets benzene ring becomes deactivated. ठीक है, because oxygen में क्या आ गया, positive charge आ गया. Now if it is positive charge, then it is pulling electrons, right? Here we have OCH3, the presence of H2SO4. Hydrogen and a positive charge here. Now, when you have positive charge, it will be pulling electrons, right, from the benzene ring. And if it is pulling electron from the benzene ring, what is going to happen? The benzene ring will become deactivated. This is what I mean, Mohammed Umar. Okay, so whenever you have electrophile, na, if you will have electrophile here, the benzene ring ko kya hona chahiye? Benzene ring should have more electrons, right? But this positive charge here, it is pulling electrons from the benzene ring, which is making the electron density here. The electron density here is decreasing, and that is why this attack cannot take place. Got it, Mohammed Umar? Okay. Just a second. Enough, Mohammed Umar? There is one good question about ethers in your NCERT. Let's do that actually. Write this question, we'll do this question, and then that's the end of the chapter. Once again, what you have to study on your own is commercially important alcohols and ethers. I think ether is not there, maybe. The commercially important ethers are not there, obviously. मार खाइएगा आप उमर हमसे, अभी तो कराया आपको, देखिए, you have already done, ना? ये क्या है? अगर इसको आप टॉलुइन ले लीजिए तो ये 2-methoxytoluene हो जाएगा, राइट? मोहम्मद उमर,
Sir, how you decide whether to name it toluene or anisole?
दोनों दोनों नहीं, डिसाइड करने की जरूरत ही नहीं है, दोनों चलेगा, बोथ आर
Both?
फाइन।
Yes,
हाँ,
sir.
बोथ आर फाइन। Chemists usually they use toluene more often because toluene is more generic and toluene का यूज ज्यादा होता है, इस वजह से ज्यादातर किताबों में आपको toluene दिखेगा, लेकिन there is no problem if you write 2-methoxy anisole. Sorry, 2-methyl anisole, okay, not methoxy anisole. अच्छा, ये सवाल देखते हैं। Which of the following is an appropriate set for the reactants of preparation of 1-methoxy? पहले आप ये बनाइए, ठीक है, 1-methoxy nitrobenzene, this one. So when you will make this, you see that you will have OCH3 here and nitro group here, right? But this nitro group has nothing to do, because you can see in both of these reactants we have the nitro group, right? We have the nitro group in this reactant also. You have to choose one of these reactant and this reactant also. And it is also present in the product. That means nitro group is not playing any role in the reaction. Nitro group is not playing any role in the reaction. It is there in the reactant. Either you choose one or you choose the second one. In both of the cases, nitro group is there, and in the product also nitro group is there. So what you have to see, whenever you want to make this type of ether, what is the set that you have to choose? Tell me. From Williamson ether synthesis. Look at the last class and tell me, इसको कैसे बनाया जा सकता है?
We have to take the carbon which is less hindered.
हाँ, उसको क्या करेंगे? मतलब वो किसके साथ जाएगा? मतलब हाइड्रोजन एटम के साथ जाएगा या फिर ONA के साथ?
Sir,
A और B?
Yeah, sir.
A और B, मतलब आंसर कीजिए चार्ट में प्लीज। A और B, मतलब 1 और 2। आपने सही कहा है साहब। हाँ, ओके नबी, समयरा करेक्ट। देख के बताइए जिनको थोड़ा सा भी कंफ्यूजन हो रहा है ना, प्लीज लुक एट द नोट्स फॉर विलियमसन ईथर सिंथेसिस एंड देन यस, खालिद करेक्ट। यस मैथ्यू करेक्ट। नाइट्रो को तो देखिए ही मत, ओके, नाइट्रो को आप देखिए ही मत। आस्था करेक्ट, वेरी गुड, कीप ऑन गोइंग। अच्छा, यस मैमुना, वेरी गुड, करेक्ट। Still waiting for others. Saif, Nabil Khan, Nawal has not answered. I think Salman has also not answered. Please look at Williamson ether synthesis in which we have made alkoxy benzene. And we have also written some note there. सैफ आप सही बोल रहे थे, आप गेस मतलब आप ट्राई कीजिए, इसको थोड़ा वर्कआउट कीजिए। यस नवाल करेक्ट, वेरी गुड। हिश्मा वेरी गुड, करेक्ट। यस मोहम्मद उमर, वेरी गुड। स्टिल वेटिंग फॉर सलमान, सैफ, नबील खान। नबील खान आप भी कर लीजिएगा, लेकिन आप एक बार प्लीज देखिए, ठीक है, नोट्स में देखिए, पढ़िए, ट्राई टू क्लासिफाई इट। हाँ, लेकिन लेस हिंडर्ड क्या होना चाहिए? यस नबील खान, वेरी गुड नबील। यस मोहम्मद उमर, लेस हिंडर्ड क्या होना चाहिए?